All right, hello again, everybody. Tonight we're going to talk about how to find the prime factorization of a number. But before we can do that, we need to make sure that we have defined some very important terms. In particular, we're going to talk about prime and composite numbers, and then we'll talk about the definition of a prime factorization. So a prime number is a number that cannot be divided evenly by any number other than 1 and itself. So for instance, the number 11, we know, can only be divided by itself and 1. There's no other number that could evenly divide it, okay? On the other hand, 12 can be divided by several numbers other than just 1 in itself. For instance, it can be divided by 6, could be divided by 2, by 4, and 3. So there are a lot of numbers that evenly divide 12. So 12 would be considered a composite number. A prime factorization is a process of determining the set of prime numbers that multiply together to make the original number. Okay, so we're looking for a set of numbers that are all prime, and when you multiply them together, they give you the original number. So for instance, we might have the number 12, okay? And we know that the number 12 can be broken down as 6 times 2, or we could say that it's broken down as 2 times 2 times 3. So if you look at this, note that 2, 2, and 3 are all prime numbers. So 2 times 2 times 3 is our prime factorization of 12. All right, now in order to find our prime factorization, we have several steps that we're going to need to follow. The first thing we're going to need to do is to write our number so that there's plenty of space below it. Then we're going to come up with some factors that multiply together to give us the number we started with. And then we're going to go from there. But as we go through these steps, I think it's going to be important to see an example so that we can understand what those steps mean. So let's try the number 63. Now the number 63, note that I first wrote it down so that there's plenty of space below it. And the number 63, using our divisibility rules, we can tell that 63 is going to be divisible by 3. We just don't know what that other factor is going to be. So let's divide it out and see what we get. So 3 goes into 6 2 times. 2 times 3 is 6, and 6 minus 6 is 0. If I bring down this 3, 3 goes into 3 one time, and that leaves me with 0 remainders. So I know that 3 times 21 would give me 63. So I'm going to write that just below 63. And I'm creating a factor tree here. Some of you may have learned about this in elementary school. So note that step 3 says identify whether these numbers are prime or composite. Okay? If the number is a prime number, we're going to circle it. And if it's a composite number, we're going to put a box around it. So 3 is a prime number. I'm going to go ahead and circle that. 21 is a composite number, so I'll put a box around it. And then step 4 says to repeat steps 2 and 3 with any composite numbers. So we're going to look at our two factors here. We had 3 and 21, and we said that 21 was a composite number. So now we're going to go back to steps 2 and 3, and we're going to do the same thing all over again. So what are two numbers that multiply together to give us 21? Well, we know that 3 times 7 gives us 21. So again, 3 is a prime number, so we're going to circle it. 7 is also a prime number, so we'll circle that one as well. So this leaves us with only prime numbers. Okay, so if we write this out, we've got 3 times 3 times 7. If we multiply these out, we can test our theory and see if we get 63. Okay, so 3 times 3 is going to give us 9. 9 times 7 we know is 63, so we are indeed correct. This is our prime factorization. So now let's try another example. Let's try the number 84. So if we look at this number 84, right away we can tell that this is going to be, because it's an even number, we know it's divisible by 2. Right? So let's break it down. We've got 2, and we know that 2 multiplies by 42 to give us 84. Now 2 is a prime number, so we're going to circle it. 42 is composite, so we're going to put a box around it. And 42 can be broken down. Again, notice it's an even number, so this can be 2 times 21. Let's put a circle around that 2 because it is, once again, a prime number, and 21 is composite, so we'll put a box around it. Now, are we done yet? No, we're not, because we still have a composite number down here. I know that we had 2 steps in our last problem with 63, but this one, remember, we're just going to keep going until we have all prime numbers. So 21 breaks down to 3 times 7. 3 is prime, and 7 is prime. So now we are done, right? And we've got 2 times 2 times 3 times 7. All right, and if we'd like to, we can check our answer by multiplying this back out. 2 times 2 we know is 4. We got 4 times 3 times 7. 4 times 3 is 12, and 12 times 7 is 84. So we are correct. So now that you've seen a couple of examples, I'd like you guys to try a problem of your own. See if you can find the prime factorization of 45.